So let's have an example of performing Gauss-Jordan elimination. So we are asked to use Gauss-Jordan elimination to solve this system. So first, what we need to do is to write it in augmented matrix form. So we're going to have the matrix here is 1, -2, 3, and 9. We have x here -1, y 3, no z, so that is 0. Then we'll have -4, then we'll have 2, -5, 5, and 17. So this is our 3 by 4 augmented matrix. Just like what we're doing, we need to write this in row echelon form using elementary row operations. So we'll start with that. And as we know, to start with that, since our term here is already 1, we just need to make this entries here rather, not term, but entries here to be zeros. So to perform our row operation here, we need to make this term, this entry rather, and this entry 0. So for row 2, I can just add so that this will become 0. So for row 2, I'm just going to have row 1 plus row 2. Let's write it into a different color. There you go. And then for row 3, I need to make this 0, so I need to have this as -2. So therefore, for row 3, I can have -2 times row 1 plus row 3. So, since I will not touch row 1, I'm just going to copy 1 rather, -2, 3, and 9. And then for row 2, I'm going to have 1 plus -1 because row 1 plus row 2, 1 plus -1 is 0. -2 plus 3 is 1. 3 plus 0 is 3. 9 plus -4 is 5. Whereas for row 3, we're going to have -2 times 1 is -2 plus 2 is 0. -2 times -2 times -2 is +4 plus -5 is -1. -2 times 3 is -6 plus 5 is -1 again. -2 times 9 is -18 plus 17 is -1 as well. So there we go. So in Gaussian elimination, we are just going to make this as 0. So let's do that. So I'm going to write it with a different ink. I'll write it here. So let's have row 3. To make this 0, I just need to add again this term and this entry and this entry. So therefore, just going to be row 2 plus row 3. So first, let's write those that will not be touched. That's 1, -2, 3, 9. Our row 1 and our row 2 is 0, 1, 3, 5. So therefore, our row 3, 0 plus 0 is 0. 1 plus -1 is 0. 3 plus -1 is 2. 5 plus -1 is 4. Alright. Now, in this case, we just need to turn this 1 and then do back substitution. However, in Gauss-Jordan, it would be better if we turn this to 0 because we need all of these, this entry, and this entry to be 1, while the rest on their columns will be zeros. So let's immediately turn this to 0. And to turn this to 0, I can use 1 here. Just like how I can turn this to 0 by using the 1 on row 1. Since this is 0, this will not be of much help. This will be the one that we will be using to turn this to 0 already. Therefore, I'm going to have row 1, there you go, row 1 would be equal to 2 times row 2 plus row 1. So that row 1 will change. So first, let me just write the rows that will not be changed. That's 0, 1, 3, 5, and 0, 0, 2, 4. While row 1 will become, so 2 times row 2, 2 times 0 is 0 plus 1, that's 1. 2 times 1 is 2 plus negative 2 is 0. 2 times 3 is 6 plus 3 is 9. 2 times 5 is 10 plus 9 is 19. So as you can see, the first two columns are now both just zeros here and then the leading ones there. So we're going to do the same here. We have to turn this to 1 and turn these other entries to zeros. So to turn this to 1, I can divide everything by 2. So I will have row 3 is equal to 1/2 times row 3. Oops, sorry. Let's change that color. There you go. That is better. So first, let's rewrite the rows that will not be touched. 0, 1, 3, 5. Let's make that bracket longer. So let's erase that. There you go. Now for our row 3, we'd multiply everything by 1/2. So this 2 will just be 0. 1/2 times 2 is 1. 1/2 times 4 is 2. So as you can see here at this part, well, we already have an answer here, but we'll go to that in a while. So now let's move to moving this and this, or making these entries as 0. So let's just move that up. So we'll continue here at this side. So to turn this to 0 and this one to 0, we're just going to use the same step as what we've been doing, using this specific number 1. Therefore, my row 2 would be negative 3 times row 3 plus row 2, so that this gets cancelled to 0, while my row 1 rather, my row 1 here will be negative 9 times row 3 plus row 1. So let's apply these. So let's have the brackets. So first I'm just going to write row 3 because that's the one not affected. 0, 0, 1, and 2. So first, let's do row 2 from bottom to top. So of course, negative 3 times 0 is 0, plus 0 here is 0, plus 1 here is 1. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 2 is negative 6, plus 5, negative 1. Alright, and then, on the one on top, for row 1, of course, negative 9 times 0 is 0, plus 1 is 1 here, plus 0 is 0 here. Negative 9 times 1 is negative 9, plus 9 is 0. Negative 9 times 2 is negative 18, plus 19 is 1. Now, as you can see here, we already have our leading ones, and the ones with their column are zeros, and those without the leading ones, we have these ones here. Thus, from this line on top, from row 1, we can then say that x, which is, well, these, is equal to 1, y is equal to negative 1, these are all y's, y equals to negative 1, and these are all z's, so z is equal to 2. So based from this reduced row echelon form, we already have the answer of our system. And that is one example of Gauss-Jordan elimination.